In this exercise, we will be combining data from two different files into one data frame. So this is an example of combining and merging data. And in this exercise, we will be doing this operation using concatenation and then using merging or joining the two data frames. So we have two files coming from the World Bank data website. One of them is about the world population, and the second file is about the GDP per capita. And the question is asking us to combine and reshape the final data to look like one data frame that has these columns here: country name, country code, population, GDP per capita. So let's load the data and see how the data looks like in the files themselves. So if we take a look at the head of the population, as we can see here, we see that this data frame has multiple columns, including the country name, country code. It also has the indicator name, which is population, and the internal code. But as for the year, instead of listing years of multiple observations in multiple rows, like for instance, country Aruba has years in the columns. So again, this is called the wide format because all of the values pertaining to each one of these years are in the same row in a different column. The question here is then asking us for two things. One of them is to reshape the data so that we have years in a long format. So each observation for each year will be in its own row. And then, of course, combining the two data sets. If we take a look at the GDP per capita, we can see that it's the same format. We have a wide format. We have country name, country code. The indicator name is GDP per capita, but we have the values for each observation over the columns. We also notice that we have many missing values here. So let's go ahead and first reshape the data. So in each one of the data frames, we want to convert this wide format to a long format. This is a very common operation since the choice of wide versus long is often a choice of convenience. Wide format is useful if we only have one value and we want to benefit from showing these values on the other axis. Long format is the format usually used by many statistical packages and machine learning packages. So many often we would like to convert data into the long format. Now, particularly in our context, we want to use long format because now we have two values to show, population and GDP per capita. So for a wide format, this means that we will have to show two values for each cell. A long format will be much more convenient. So how do we convert from a wide format to a long format? The function that helps us do that is called stack. And stack basically will take the column axis and stack it as a second level on the row in the row index on the row axis. Okay. So this implies that we want to stack only the year values. We want to exclude all of these columns: country name, country code, indicator name, and indicator code. But we also want to keep these values as well. Because we want to stack values, we want to know for each country what is the corresponding year for this value. So what we're going to do first, we're going to change the index. We're going to set the index to be country name, country code, and then indicator name will be population, so it's only population here, so chances we don't need it here. And if we do this reset index, you can see that we have a new index being country name and country code. Okay. Now those two columns, indicator name and indicator code, we don't need anymore. So because what we're going to do, we're going to stack all of these observations in one column, and we're going to call it population. So what I'm going to do, I'm going to select out these two columns. So there are different ways to do this. One of them is to drop the columns using the drop function, or we can simply do iloc. Since those are the first two columns, I'm going to select all rows, and I'm going to select columns 2 onwards. And again, remember that doing iloc using location-based indexing. So this is 0, 1. Column 2 is 1960 onward. So this basically drops out those two columns from the data frame. Now next, what I'm going to do, I'm going to stack this data frame. So if we stack this data frame, what you can see here is that we got ourselves a series. And this series has a multi-index, multi-level index. In this case, we have the first level being the country name and the country code. And the second level is basically the values of the column axis. Right? That's the notion of stacking. We converted the column axis to a level within the row axis. And here we have the value for each one of these. Okay. So that's our series. And we can keep it as is, and we can combine it with the other data set as a series and make the final conversion as a data frame. Or we can simply reset index here, and reset index will basically use the default index from 0 to length -1, but all of what we have in the current index will be pushed to being columns in the data frame. So if I reset the index, I'm going to get a new data frame here, which has the country name, country code, level 2, and the value of level 2, right? So what's missing here is basically renaming this level 2 to be population, to be year, and 0 to be population. So I'm going to save this as a population data frame. Let's call it popdf here. And then what I'm going to do, I'm going to rename the columns of popdf to be columns. Well, those will be the same, so I'm going simply to copy paste those values. So column name will remain the same. Sorry, country name will remain the same. Country code. Now level 2 will be year, and of course 0 will be value. And I'm going to do head just to see what we've got. All right, so it looks like what we are looking for. We're going to have year, country name, country code, and the value. Instead of value, this has to be population. All right, it's the value of population, so we want to call it population simply because we will have another value in a moment. So let's not worry about rearranging the columns. We will do that at the end. But what we're going to do, we're basically going to apply the same transformation, since this is exactly the same data frame, to GDP per capita. So let's apply this at GDP per capita. I'm going to call this GDP data frame. And instead of population, of course, it will be GDP per capita. So we do this data transformation and we get the results here. All right, so the next step is to combine these two data frames. So what we need to do here is to figure out how we want to combine these two data frames. Now, because these two data frames are rows in a final data frame, we can just safely stick them together as rows, right? And this is one way to combine them is to have population and GDP per capita as two columns in the final data frames. What this is asking us to do is to stick them together side by side. So to have population here and to have GDP per capita here. So we want to combine these on the column axis. So right now we have two options. One of them is using concatenation, pd.concat, and the other one is using joining, pd.merge. So the difference is that pd.concat will just stick them together side by side, whereas pd.merge will merge based on a certain condition, matching values. So pd.concat, in order for this operation to be safe, these two data frames have to have the same length, otherwise there's something missing. So if you do length GDP data frame here, dot head, you can see that these two data frames have a different length. This is not surprising because of the missing values. So what happened with these missing values is that when we did the stacking operation, those values, the values that had a missing value were dropped. Now, if we compare the length of population and length of GDP per capita as coming from the original data sources, they have the same length. More specifically, they have the same size, the same shape. If we do shape, 264 rows, 64 columns, and if we do GDP per capita, the shape, they also have the same shape. So because we dropped the missing values here, this resulted in two data frames of different length. Then if we do pd.concat, this will result in an incorrect outcome in the sense that we will stick this row side by side to this row and we will get a value for year 1960 associated with a value of year 1986. So let's see that. Let's do popdf and gdpdf, and axis is 1 because I want to stick at the columns here. Okay, so you can see here the mistake, right? The data is not aligned properly, which means that this row, well, everything is incorrect basically, and at the end of the data frame you have some missing values. Okay, so dropping the missing value didn't work out well for us. We need a way to keep these missing values inside the data frame. So let's backtrack and take a look at what happened here. When we did the stacking operation, we had these missing values were dropped out from the data. Okay. So what I'm going to do here instead, before doing the stacking operation, I'm going to replace these missing values with something else that indicates that they are missing. So what I'm going to do, I'm going to fill NA with -1 and then do stack. Now, if I do this, as you can see here, you can see that the missing values have a value of -1. So in pandas eyes, those are not missing values. This is just a marker value I'm using here in order to keep these observations. So then what I'm going to do here, I'm going to return to the previous code, the code that I took out, reset index here. And this is what we get, okay? Now if I do the length, you can see that they have the same length, or they don't, so we're still in the same situation. And this suggests that there is an issue concatenating these two data frames. Assuming that they had the original length, then we could have gone further and proceeded with the concatenation operation. So what we can do in this case, we can replace that -1 with not a missing value again, and now we get the missing values. Okay. So if this is the case, assuming that they have the same length, we can concatenate them and be sure that the corresponding values will align. Okay, so as you can see here in year 1960, that was a correct matching in between the two between the two rows in the two data frames. But of course, they don't have the same length, which means at some point there was an observation in GDP per capita that was not included in the population data frame. So this serves to show the limit of using concat unless the two data frames are coming from a well-managed data source, and both they have same rows, same number of rows, same values for the same countries in the same years exist in both of them. Concatenating the two data frames, just sticking them side by side, is not a good idea because, as you can see, we're assuming that they have the same shape, so it's safe to stick them together. This doesn't seem to be the case in this example. So what I'm going to do now, I'm going to do merging instead of concatenation. So let's take a look at population GDP-DF head and population DF.head here. And what I want to do, I want to match based on the country name, country code, and year. Now, of course, country name and country code I can choose in between, right? Hopefully the data is consistent, so always the country will have the same country code. But I have to include the country and the year in the matching condition. So different ways to do it. What I'm going to do here, I'm going to use pd.merge, and I'm going to merge population DF and GDP DF left on country code and year, and right on country code and year. I may still get an error because of the same column name, but looks like pandas used the default suffix of x and y here. Now this is an inner join by default, hence we get the length of 15409, right, and 6 columns. What we can do here, we can make it an outer join to keep those observations that we did not manage to match. And if we do it as an outer join, we actually don't need to put the NAs anymore. But because the outer join by default will match these that don't exist and will give us not NA in the join operation. So we can do this and we can do an outer join and we still get these number of rows. Okay, so that's the final result here. We still need to rearrange this outcome, so we can call this one final. We need to get year, population, GDP per capita. I'm going to provide a suffix here. I'm going to provide a right suffix is equal to R. is probably suffix is equal to nothing, because I want to keep the original column name and R. Let's take a look at the documentation. Suffixes, so suffixes, okay. Okay, that's an underscore here. So because I want to select country name, country code, year, population, and GDP per capita, I want exactly the same order. So what I'm going to do, I'm going to select df using a fancy index, year, country name, country code, population, and then GDP per capita. So this gets us to exactly the same format of the output. It's not df, it's final here. And that's the results here.